Good everyone, welcome to GeoTutors. So on today's episode, we are going to talk about how to pick our first arrival on a seismic refraction plot. Okay, how do we come about the first arrival? So on a sample geophone, we have points where we have, like if we have this seismic configuration array, where we have our shot, that is where we apply the source, okay, the shot, okay, at our source. Then we have our set of geophones, which is our receiver, okay, set of geophones. Good. So at this shot, either you have a dynamite blue in this place or an hammer hits very well loudly in the ground so that seismic wave can move. Then if it's hit in this place and you can see the rays will move in this direction, I see, horizontally and also incident into the ground. And also incident into the ground. So until it meets another different layer, it is now what? Critically refracted, then it's seen by the receiver. It happens again, the wave continues, hit the ground, critically refracted, receiver, critically refracted, receiver. That's one of the ways it moves. Another way it is in this manner, horizontally to the receiver. Okay, good. At a particular time, this refraction that we get tells us about the different layers, because for refraction to happen it shows that we have different layers. I mean, this layer is different from this layer. Good. Now when the source is applied in this place, okay, that is what we call our forward shot. Okay, our forward shot. Now when we place it in the middle of our geophones array, for example, we have something like this, right? If from here to here is 50, 50, I mean, from here to here is 50 between our geophones, and we now choose this point here, that's at point 25. We now shoot, this is where our shot is, have you? Explode your dynamite or hit hammer on the ground. So this guy will hit the ground and it will move critically refracted to this point, critically refracted to this point, critical refraction to this point, critical refraction to this point. And you see that this is what we call the mid shot, mid shooting. Now we also have the what? The reverse shot, whereas we replace this last this last geophone, this last geophone here. We'll put this shot at that place and move the geophones array to this point. Like, can you see that? We'll move this one to this place, move this to this, move this guy to this guy, move this geophone here, this geophone here. Then we now have this free space. Then at this point here, we now have our new shot. That is what we call the reverse shot. The reverse shot. So these are the three types of shots. And now on this video, the main purpose of this video is to be able to pick our first arrival. That means first arrival is talking about the seismic wave that first reach our geophone. Either it is by this movement or by the critically refracted movement, either this way or this way. Good. Now for here we have our forward shot. And you see, this is our forward shot. Now on this seismic refraction shot sample, we have our distance and we have our time. Good. Now for us to pick our first arrival, it's very simple. If you look at this stuff, this thing you're looking at, you find out that what they are like waves. So you see something like this, peaking and troughing, something like this. If I say peak, it means it's going up. If I say trough, it is coming down. So we're just going to pick the point before it start to peak, or the point before it start to what? Trough. The point before it starts peaking, or the point before it starts what? Troughing. Those are the things. So if it's something like, if I see something like this now, I see before it starts what? Troughing, I'll pick it. That is my first arrival. So if I come here now, I look at this wave at the distance 2, at distance 2 geophone. So I'll just say, so before it starts peaking, in this one now it is peak. I'll choose here. Can you see? Before it starts peaking. Now come here again. Can you see? Just be picking like that. Picking it. Can you see that? Can you see this one now? It is troughing. It is troughing. So you still pick it. Either pick or trough. Anyone. You keep picking, you keep picking, keep picking, you keep picking, keep picking, keep picking, keep picking, keep picking. Okay, this peak, this picking, this picking. So you see that it follows that pattern as if something that is slanting. Okay, keep picking, keep picking. Good. So that is how to pick your um, seismic refraction short sample. Now for your now this is for forward shot. Forward shot is in this one. Now mid shot, you can see like what I explained earlier for mid shot. The refraction moves in this direction and also what? This direction. Okay? Moves in this direction, also move in what? In this direction. So now you can see for below is our mid shot. Okay? So you're just going to start speaking. So you start from here. So in this one now, you know it's speaking in two manner. It's going this way, this way. So this is actually the middle of the shot. So it now starts moving this way. So you can start from the middle here and move towards the rest. So it's peaked. Can you see that? It's peaking, it's peaking, it's peaking, it's peaked here, it's peaked here. It's very, very easy actually. It's not something that is hard or complex. Okay, good. Now that is how to form your what? Your pick your first arrival on your seismic refraction short sample. When you have a short sample, this is how to pick your first arrival. Good. Now the main purpose of today's video is this, and now the second purpose for today's video is how to now form your distance time table. What I say? Your distance what? Time table. Your distance time table. Your distance time table. Your distance time table. Your distance time table. Okay? How to form your distance time what? Table. Now, distance, then we have the time. Okay? Good. Now, if you look at this stuff now, this forward shot, this for a forward shot now. You know, for a forward shot, its sample is like this. Let's say we have a distance. Your shot is always at point 0, like for forward shot, it's always at the starting point 0. Okay? Then distance between this guy and the first geophone, distance between the shot and the first geophone 1, is known as the what? We call it the offset. Offset distance. Now, then we now have geophone spacing. That distance between successive what? Geophones is always equal actually. Distance between successive geophone is always equal. So from here to here can be any number. Distance between the source and the first geophone can be any number, but the distance between the geophones are always the same. Okay, so from here to here can be 2, for example. I'm just using that for example. Why distance between your self geophone can also be 2 meters also. But know that this and this can might not be the same with the distance between geophone spacing. Okay. So 2 meter, 2 meter, 2 meter, 2 meter, from here to here, 2 meter, from here to here, 2 meter, from here to here, 2 meter. But the time between your source where you hit your hammer on the ground and this geophone is 2 meter. Good. And that's what we call our offset distance. Now, the distance and the time. We're talking this time is talking about the time where the first arrival was recorded. The time where the what? The first arrival was recorded. So that's why we have our distance here, we have our time here. Now, each of these lines here, the gap here is 4 4. From here to here, the distance of 4, like 2 plus 4, 6, 6 plus 4, 10, 10 plus 4. So it's like 4 4 distance. Okay. So we don't have anyone at 0. Because at short 0, is there any geophone at 0? So that's why for forward, um any forward distance time table, at 0 you will not see anything there on the time, because there is no, because that is where you are hitting your um that is where you blew your dynamite or your hammer or anything that you are using for your source, okay, in the ground. So if it's that time at distance 0, there's no way that you are going to receive a wave, because there's no geophone there. So it's at the next distance where you have geophone at 2 meter. Distance between here to here, we say that is 2 abi, for example. So when the thing has been critically refracted, we will see the time here. So now at distance 2 now, we saw that, can you see this line? At distance 2 now. So you will now take your ruler. You will take your ruler. Okay? You will take your ruler. Can you see this? You take your ruler. Can you see this first arrival I picked? You will now mark it up here. You mark it up here. From here to here is 20 to here is 40, abi? 20 to 20 and this 20 and 40, abi? The midpoint of here will be like 30, right? Right? And here is closer to this place. But here will be like 25. So let's say like 21, 22, for example. Normal, you're supposed to take your ruler and do your calculation. But let's just say like that one should be like 21, 22 or something. Let me use 22. Okay? 22 milliwatt seconds. Good. So at 2 distance, which is where the first geophone is, abi? The time in which the seismic wave arrived is at what? 22 milliseconds. Can you see that? You continue again. I told you that the distance between each of them is like 4 4. So this one is 2 plus 4, that's 6, abi? So at 6 meter, that's where we have the next geophone. So we'll come here again, we'll put our line. You can see this one is greater than 30, greater than the middle. So you can say 34 or something, like 34 milliseconds. Like that, like that, like that, like that. Then you form your what? Your distance time table. You form your distance time table. So that's typical for that. So for your own assignment and assessment, try to do for complete this. This is what we call the reverse shot. Okay, you can see that it's starting from down here, then going this way. Starting from down here, then going this way. Okay, this is the reverse shot. Now this reverse shot, get your distance timetable. That's your one assignment. Get your distance timetable from it, and then you can plot your graph. So in next video, I'm going to plot the graph. Thank you very much for listening to us. We are GeoTutors. Kindly subscribe to us and recommend our video to fellow geoscience and fellow geophysicists. Thank you.